Are we live?
Mm-hmm.
Okay. We're back. Video 3. I know. It's long and torturous. Just think about me here at home in my jams with my dog all day. Anyway, okay. The following table shows the pounds of meat on a sandwich. Sorry, fifth hour. I know this is tough on you guys because it's right before lunch. And the calories in the sandwich. So right now you should be asking yourself, okay, does the meat depend on the calories or does the calories depend on the meat? Is our relationship proportional? How do we find out? Remember, you can scale up. You can cross multiply. But you pause the video, work your mathematical magic, come back, and we'll decide if it is proportional or not. Welcome back. Maggie's shaking her head no. Maggie, why do you say no?
Well, it's the same as last time. Like, that it's not equal.
No, because when you take 650 and divide it by 1/2, or times it by 1/2,
You get 325.
you get 325. And when you take 1 times 560, you get 560, because any number times 1 is itself. And since we already know that these are not equal, we don't have to do any more math, thank goodness. Are you on the camera? Are you on the table?
Yes, I'm on it.
Okay, jeez, don't take a tone with me.
You doubt me.
Well, so because ratios not equal. No, you cannot abbreviate like this. I'm just doing it so you don't have to listen to me talk. But we're still going to graph it. So it says label axes using meat in pounds for the x-axis. That must mean that meat in pounds is our independent variable because meat's just meat. It's got poundage, whatever. So meat in pounds. And then how many calories you consume depends upon how many pounds of meat. So calories. And then we'll call this sandwich mania. Really exciting. Okay, so now go ahead and, we got to do our intervals. So here we got to go from 1/2 all the way up to 2.5. Also, is it going to go through 0, 0? If we don't have any meat, are we consuming any calories? We're just talking about the meat. We're not talking about the bread or the cheese or the mayonnaise or any of that other junk. It's just the meat. Nope, we don't. So it does go through the origin. So 0 to 2.5, I got 1, 2, 3, 4, 5, 6, 7, 8. Maybe 1, 2, maybe, I think I got to do this. 1, 2, go by 50 cents, because if I go 1, 2, 3, 4, 1, 1, 2, 3, 4, 2, I mean, I could do, but that, I don't want to extend the graph. And then from 550 all the way to, or 560 all the way up to 920, we've got to have the same intervals. 1, 2, 3, 4, 5, 6, 7, 8, and almost 1,000. So let's go by 250s. So I guess 125, 125, 250, 500. Okay, go ahead and do your graph, do your intervals, plot your points, come back, okay. So you can see that they are not proportional. Now we do have a line. Look at this nice line. Oh, don't you love my ruler? See if you move it. Looks like, can you see the horses running? Mm-hmm. Yeah, Maggie doesn't enjoy this. She didn't enjoy it when I was her teacher either. So it goes straight But look at this. Is this a straight line when we go from 0, 0 all the way up to here? Looks like somebody just suddenly decided to take a right turn. Okay, so it says, do you have a conjuncture, or which is an opinion or a hypothesis? I fixed my N here, sorry guys. About how to determine if table values represent a proportional relationship? So when we're looking at the table, how do we determine if it is proportional? Well, we've been doing this for like 30 days now, so hopefully you got an idea. But talk with your peeps. So hopefully you said that when you look at the table values, the ratios are equivalent. And how do we determine if they're equivalent? I should have out my little spinner so I can randomly choose people from each class. But yes, you can cross multiply. Ah, not equal. No can do. If you don't like to cross multiply, I like to cross multiply because I think it's super easy. But you can scale up. Now it says, do you have a conjuncture, which again is an opinion or a hypothesis, an educated guess, how to determine if a graph of values represents a proportional relationship? Well, this is my not proportional relationship. And this is my proportional relationship. Pause the video. Talk with your peeps. This is not proportional. Wah, 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 wah. Proportional. Zoom. I hope you guys can follow this. Do you think they'll be able to follow me?
Yeah.
I only take a few left turns. Not proportional. So pause the video. Talk with your people. Try to stay focused. I know I'm not there to watch you, and I know you're talking about other things, but you know. Maggie just asked why I pause if they're pausing the video. I'm sure you heard her whisper that. That is so that I don't just continue to talk. Then you can pause it and then start it back up. And it's like you got a little bit of time to pause and start up. So with the graph, if we have a proportional relationship, then all the ratios are equal. So we're going to go up and over, up and over, up and over, up and over at the same rate. So our line has to be straight, but in order for our line to be straight, like totally straight, it has to go through the origin. See here, when we were doing the soup for sale, we had 0, 0, but we didn't go up and over, up and over at the same rate. That's why we're kind of like wah, 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 wah. Here, no meat, no calories, but we had our straight line here, but then suddenly we veered off to the right. We said, oh, Dairy Queen, here we go. So in order for it to be proportional on a graph, it has to be straight line. And I'm going to ask you this question, I'll bet you 100 times, so I suggest you know the answer. Straight line through the origin. What's the origin? Maggie?
0, 0.
It is at 0, 0. It's right here on the graph. It's the origin. It's where it all begins. The origin is the beginning. Right here at 0, 0. 0, 0. 0, 0. 0, 0. 0, 0. 0, 0. Anyway, okay, group. Hopefully I will be back tomorrow. Please be good. Make good choices. I know. I say no phones in class, and here you are with your phones? Seriously, what the what? Anyway, okay, bye.